In these videos, we're going to be looking at two examples where we're going to use our trig functions to solve a right triangle. So we're asked to use a calculator to solve a right triangle. So solve triangle ABC. Now what that means to solve a triangle is I want to know the measurement of all three angles and the measurement of all three sides. So I'm going to start just by writing out what it is that we're looking for. So capital letters ABC represent angle measurements. So we've got capital A, capital B, and capital C. And then we're going to be looking for side lengths, so we use lowercase letters for sides. Lowercase a, lowercase b, lowercase c. Another item you might have seen in a geometry class is put a little angle symbol in front of each of these. We don't necessarily have to have those here in algebra, but we'll put them there just for today. Now, as I solve my triangle, what I'm going to do is I'm going to look at the triangle that's been given to me, and I'm going to go ahead and fill in the things that I know that, from my diagram. So first of all, I know angle C, because it's a right triangle, angle C is 90 degrees. That's no problem. I also know apparently that angle B is equal to 32 degrees. Fill in 32 right here. Now, finding angle A, well, I have the third angle of my triangle. I know from geometry that if I add up all of the interior angles of a triangle, they're supposed to equal 180 degrees. So I've got 90 degrees taken care of right here in the corner. That means there's 90 degrees left for these two angles. So if 32 degrees is used up right there, well, then my thought process is this. I'm going to take 90 degrees and subtract 32 degrees from that. Doing a little bit of mental math, or if you need a calculator, that's okay. We come up with 58 degrees for the measurement of angle A up in this corner. So I'll go ahead and write in 58 degrees as one of the answers that I'm looking for. Now, finding the three side lengths, I start with the one that's given to me. I'm told that side A is a length of 10. Now, here's where I have to use my right triangle trigonometry ratios to solve for the other two sides of my triangle. And typically, you might think, well, I can use a Pythagorean theorem. Well, Pythagorean theorem requires that you know at least two of the sides to find the third. Here I only know one, so I'm going to have to rely on the fact that I know an angle in the triangle. Now, here's what I mean by that. If I want to find, let's say, angle B, or side B, excuse me. I want to find this side right here. Well, I know 32 degrees is the angle that's opposite that side. So when I say opposite, I start to think about my three basic trig functions, sine, cosine, tangent, and I try to remember which ones involve the opposite side. Well, SOHCAHTOA, so sine has opposite, and it's opposite over hypotenuse. So I take a look, okay, the sine of 32 is going to equal the opposite side over the hypotenuse. That's not going to help me though, because I don't know the opposite side and I don't know the hypotenuse either. There'd be two variables, that's too much, I can't solve that. So then I keep thinking, well, TOA at the end of that SOHCAHTOA is tangent equals opposite over adjacent. So I'm looking for the opposite. Oh, look at this. I know the adjacent side. So that tells me is that in order to solve for the opposite side, given an angle of 32 degrees, I'm going to use the tangent function. Here's how I set this up. I'm going to write the fact that the tangent of 32 degrees, the angle that's given to me, is equal to the measure of the opposite side, B, over the measure of the adjacent side, which happens to be 10. Now I have an algebraic equation that I can solve pretty quickly. So my job is to solve for B. What is the value that makes this work out? Well, if I'm solving for the numerator, I multiply by both sides by the denominator, and I get B is equal to, I'm going to turn this around, 10 times the tangent of 32 degrees. Now the directions said to use a calculator to do this, and that's exactly what I would want you to do next. On my calculator, I'm supposed to take 10 times the tangent of 32 degrees. Well, here's how that works. I type in, well, first, a little quick note calculator-wise. Before we work with trig, if we're working in degree measurements, which we are at first, you need to change the mode on your calculator. So mode is up here. I need my calculator to not be in radian mode, but instead to be in degree mode. Hit the down arrow as many times as you need to. Right arrow to highlight degree, hit enter to make sure that it's in degree mode as we're working here. Now, the radian degree thing probably hasn't made a difference for a lot of the stuff that we worked with so far, but it will now as we get into trigonometry. So now that we're in degree mode, If I quit, that takes me back to the main menu. Now I go ahead and type in the expression I'm supposed to evaluate. So the length of side B was equal to 10 times the tangent, TAN right here, of 32 degrees. Now, because I told my calculator I'm in degree mode, I'm good to go. I close the parentheses and I hit enter. So 10 times the tangent of 32 gives me 6.2486. Now, usually I'll round this to 2 decimal places. Okay, just kind of pick an arbitrary place to which to round our number. So I'm going to go ahead and write down 6.25 as the answer to this expression. So B is equal to 6.25. I'll go ahead and fill it in right here. B is equal to 6.25. Now I've got one more side length for which to solve. And you might be thinking to yourself, well, now that I have 2 sides, could I use the Pythagorean theorem? Yes, you could. My only caution to you would be, maybe we got this wrong. You're now using a number that we figured out at home, and there's a chance that we did that incorrectly. Or maybe because of the way you rounded it, when you use it, a rounded number in an equation later, it would give us an inaccurate answer. Now, would it be close? Would you get away with it? You probably could. But in order to be as exact as possible, I'm going to say we're going to use another trig function to find C. Now we're going to use the angle that was given to us, which is 32 degrees. So again, we have to think to ourselves, what's the stuff that we know and what are we trying to find out? Well, I know 32 degrees is my angle. I know the side that is adjacent to it. And I'm looking now for C, which happens to be the hypotenuse. So which of my trig functions relates the adjacent side to the hypotenuse? Well, running through again, so ka toa, the cosine, is adjacent over hypotenuse. So once again, I'm going to set up a trig equation. I know that the cosine of 32 degrees is equal to the adjacent side, which is 10, divided by C, which is the hypotenuse. So here I have another equation that I need to solve. I'm solving for C. Because C, the variable that I want, is in the denominator, I'm going to go ahead and have to switch the C and the cosine of 32. Here's why that works. I multiply both sides by the denominator, C, which cancels out that denominator. So I have 10 is equal to C times the cosine of 32. But then I need to divide by the cosine of 32 degrees in order to get C by itself. So I have 10 divided by the cosine of 32 degrees. Now, the more you work with this, the more comfortable you get. And you'll be able to look at the expression I had in green, and you'll just be able to say, oh, take these and switch them. Okay? Take these and switch them. We'll have C by itself. We'll take 10 divided by the cosine of 32. Now, back to where we had it. What I've got is C by itself now. And C is equal to 10 divided by the cosine of 32 degrees. Once again, I'll use my calculator to evaluate this expression. We're going to take 10 divided by the cosine of 32 degrees. Now, you could probably get away without the parentheses, but I always want to make sure I close them so my calculator knows you're taking the cosine of 32. When we get into more complicated expressions, those parentheses will be more and more important. It's good to practice that now. When I'm ready to go, I hit enter, it evaluates, and I get 11.79 for the value of C. I'll go ahead and write that down. C is equal to 11.79. And then I fill that in my chart of the things that I need to know. C is equal to 11.79. And then I think it was, does that make sense? I just found the length of the hypotenuse. So the hypotenuse needs to be longer than both of the shorter legs. So 11.79, is that bigger than 10 and bigger than 6.25? Yes, it is. And do the sides 10 and 6.25 match up with the angles? Well, 58 is a bigger angle than 32, so the side opposite 58 is going to be bigger than the side that's opposite 32. So once again, to recap, we were asked to solve triangle ABC, and we have now done that. We found angle A, we found side B, we found side C. Given these other 3 items, I now have a solved right triangle.